Okay, pre-calculus students. Thought you'd get a kick out of looking at where we've gone. In the table of contents for that unit we were working on for quite a while, you owe me a homework for inverse trigonometric functions right here. And since I'm not with you, you have to hold on to it till we see each other again. And today, we're going to do composition of trigonometric functions, which relies on the last lesson that I lectured pretty heavily. And then look what's left. We're done with this unit. That means there's a test right around the corner. So let's get to it on what composition means. So this is preparing us for, I'm calling it lesson 15. Composition of trig functions. Composition means to put two functions together. If you recall, well, I think I can even do the notes right here. If we have two functions, one is called f, and then we spend the work and we find its inverse, we can put them together and say f of the inverse of x will give you, we've done this before, x. Or you could do f inverse of the function, and it also gives you x. Let me remind you of a problem. Okay. Let's see, f of x will be equal to, we'll do something simple, 5x minus 2. And I'm going to find its inverse, which means we have to call this function y, because that's what f really means. And I have to switch the x and the y around. So before I to find that inverse, let me do the work. 5y minus 2 now equals to x. Solve this for y. 5y will equal to x plus 2. Y will equal to x plus 2 divided by 5. This new y is the inverse of x. Pause it if you need to. So I have f and I have f inverse. If I want to do composite, and I take f and I plug in the inverse of x, would look like this. Everywhere you see x in f, I plug in the inverse function, because the inverse is inside. So f is eating f inverse. So that looks like 5 times x plus 2 divided by 5 minus 2. F times x plus 2 divided by 5 cancels out the 5. I'm now left with x plus 2 minus 2, which is equal to x. So now if I want to do f inverse of f of x, what that means in English is all of f, this one here, gets plugged into the x of the inverse function. In other words, the inverse right here is eating the f function. So that would look like this. All of f, which is my 5x minus 2, goes here. 5x minus 2, all of that function. Add 2, divide by 5. Let's clean that up. X minus 2 plus 2 over x, over 5. The minus 2 plus 2 cancel. I lost my 5. Let me put my 5 there. It was a 5x minus 2. 5x plus 2 minus 5x minus 2 plus 2. They still cancel, leaving 5x divided by 5 equals to x. There it is. Both got me x. That is the magic of composition of functions when you're dealing with a function and its inverse. What does that have to do with trig? We've been doing trig inverse. So it makes sense that we'll talk about if f is sine, then the inside function could possibly be inverse sine. F would have been in this case the outer function sine. F inverse is inverse sine. And if you do f of f inverse, you get x. But the domain is dependent on the inside function. So the domain of inverse x, of sine of x, if you recall, when we graphed the inverse sine from left to right, it went from -1 to 1. Do you recall that was the range of sine? Therefore, it's the domain of inverse of sine. Okay, so another property. If your outside function is f of x, which is cosine, inside function is the inverse of cosine, in this case, inverse sine, then when you take the cosine of the inverse sine, we get x. That's the property of composition of function and its inverse. This only applies for the domain of inverse cosine. And if you recall, the domain of inverse cosine was the range of cosine, so it also becomes -1 to 1. This is from the last lesson. Inverse tangent is being compositioned with the inside function of inverse tangent, then it would simplify to x. And don't act like you don't know what I'm talking about, because I just did a whole function over here where I found its inverse, and I showed you the two compositions of f with its inverse being in the middle, inside, or with the f being the inside, and each time we got x. So I showed you proof that it does that, and these are your properties that we say happens all the time. So now, but this is restricted domain, okay? This is a restricted domain. And there's also restricted domain on the algebraic ones too sometimes, but nonetheless, the arc tangent takes on the domain of the range of tangent. So in this case, if you recall, tangent goes up forever and down forever because of asymptotes. Therefore, the domain of arc tangent would go left forever and right forever. We didn't do that in the homework or in the notes, but so I'm telling you, just use some common sense. Tangent went forever up and went forever down. Therefore, inverse tangent has to go left forever and right forever. Let's change it around and talk about the outside function being the inverse function, and the inside function is the regular function. So arc sine of sine will be x. But that only applies to the domain of sine, the inside function. The domain of the inside function, the domain of sine, always went from, or I said it wrong. Yeah, the domain of sine went from negative pi over 2 to pi over 2. If you recall, we were only graphing sine from here, and we literally stopped here. We stopped here, then we stopped here. Remember? That's all we graphed sine. We graphed only up to pi over 2 and negative pi over 2. Cosine, we went from these two quadrants. So cosine, if the outside function is inverse cosine and is eating the cosine function, the definition is that's x. Only on the domain 0 to pi. The tangent function, if we were to have used it, we did use it, we just didn't graph it. We take the same restricted domain as sine. So this also used quadrant 1 and quadrant 4, but only as a negative. Positive angle, negative angle. So that also went from negative pi over 2 to pi over 2. Okay? Those are just properties. Most of the time, you forget what that was all about. The proof in the pudding is using this. So first problem. If I take the sine of an inverse sine, these two should cancel each other out, remember? So this one's easy. Sine of an inverse sine of something will be the something. Well, that was easy. You literally could key that in a calculator and say sine of the inverse sine arc sine of negative 1/3. But we're not using calculators. We're using common sense. Arc cosine of cosine are inverse functions. They cancel each other out, leaving what's left, pi over 4. Well, that's easy. What an easy lesson. The concept's not easy. Arctangent of tangent cancels each other out. Look at this. We're almost done with our lesson. Easy. Easy as pie. Arctangent. Oh, it suddenly did not get easy. Arctangent of arctangent does not cancel out, does it? I have to be totally honest with you. I don't know the answer. I can't, because 9/2 is not a special. The tangent of what is a 9/2? I don't know. I think the author made a mistake, because look at all the other problems. Look at the last ones I've done. I think the author made a mistake. I think that's a typo. I think the author meant to say tangent of inverse tangent is negative 9/2. I could be wrong, but there's no way to do that original problem in your head. There's no way. It has to be special angles or on the unit circle. Look at the next one. Same thing. Look what happened. He went arc sine of sine. So that's what these were. Arctangent of tangent. This was tangent of arctangent. They're all inverse of each other. So I think the author made a typo on number 4. I'm going to just run with that. Arc sine cancels out sine, leaving 3 pi over 4. I got kind of scared for a moment there on number 4, but I think cosine of arc cosine cancels out. Well, when does it get hard? Arc sine of sine cancels out. Arc cosine of cosine cancel out. When is a shoe going to drop? But I'm concerned that this is just way too easy. So maybe you ought to go to your calculator and double check. I would pause this right now and I would see if this is working. Pause it right now. And I want you to find some mistakes. I'm waiting. Did you find a mistake on number 1? Probably not. Because the question was the inside function. I'm going to take the inside right here. Sine of what is equal to a negative 1/3. That's not a big deal. The reason I say it's not a big deal, the sine function can be a negative 1/3 because sine can go all the way up to 1, all the way down to a negative 1. That should be okay, no error. Number 2. If I just do this part here, cosine of pi over 4, that's easy. We know the cosine of pi over 4. Cosine of pi over 4 was, wait for it, 1 over the square root of 2. That's before I fix it. I don't have to fix it. That's what it was from my triangle. 1 square root of 2. Cosine of that angle is 1 over the square root of 2. Fine. So now this becomes arc cosine of 1 over the square root of 2, which is asking me cosine of what is 1 over square root of 2. We just did it. Cosine of a 45 degrees is 1 over the square root of 2. X is pi over 4. So my answer is correct. Okay, I guess maybe I was false alarm. Let's try this one. When I do arctangent of pi over negative pi over 2, pay attention to this problem first. Tangent of a negative pi over 2. Oh. Uh-oh. Can you take the tangent of a negative pi over 2? As I recall, tangent had asymptotes at negative pi over 2 and pi over 2. You should get an error in your calculator because you can't take the tangent on an asymptote. It doesn't have a value. So we got so excited because we weren't paying any attention. This does not exist. You mean we actually have to pay attention to what we're doing? Yeah, you really sort of do. How about number 4? Okay, I did tell you that I think that it didn't have 2 inverse tangents. Can I take the tangent, if I say arctangent negative 9/2, can I say what angle, or tangent of what angle, tangent of what angle is negative 4.5? Can the value of tangent ever be a big number? Well, of course it can, because the tangent can go all the way up to infinity and down. So that's not a big deal. I can do this inside. Therefore, I can reverse it and come back to negative 9/2. Okay, I told you the shoe was going to drop, and it did on number 3. How about this one? Were you paying attention? The inside says sine of 3 pi over 4. 3 pi over 4 is 145 degrees, 245 degrees, 345 degrees. In English, that is a 135 degree angle. So doing the trig, doing the inside first, you'd have to drop a perpendicular here. Realize this is a 45 degree angle, reference angle, meaning that's a 1, that's a negative 1, that's a square root of 2, and the sine of this reference angle is opposite over hypotenuse, 1 over the square root of 2. So the problem turns into, see, this was we're questioning this answer, arc sine of a 1 over the square root of 2. bothered by it? Is that okay? This interprets the sine of what angle is 1 over the square root of 2. Sure seems like I could say it's this big angle here. It seemed to work. But, and theoretically, it is working. The only problem is, this was a trick question. We're forced to talk about what the domain is for the arc sine. The domain of arc sine can only give us answers. Your calculator will only give you answers in that quadrant. So in those two quadrants, from negative pi over 2 to pi over 2, 3 pi over 4 is too big. 3 pi over 4 goes all the way into quadrant 2. So yes, you can key this in your calculator, and I think it'll give you this answer. And in all practical worlds, we would run with it. But it is possible the author says does not exist because of a domain problem. So that's an example where your calculator technically lies to you. It does find that angle in quadrant 2, though. I would have ran with that 3 pi over 4 answer without double checking the domain of what arc sine can be. I know a lot of you are bothered by number 5, why I'm telling you it doesn't exist. But just be honest with yourself. We did write this up here. Doing the arc sine of sine, we have to limit our domain. You see it right here? Negative pi over 2 to pi over 2. It's not fair because you're relying on your calculator. You mean we have to think too? Yeah. Arc cosine of 2/5. Can I take the cosine of that answer, whatever that becomes? As long as the value you're going to get inside here is between -1 and 1 would be okay. I can take the cosine of anything between -1 and 1. So the question here would be, that's a 0.4. Do you suppose that there's a cosine of some angle could be a 0.4? Sure. The cosine of some angle could be 0.4. So some angle could exist. So then you can do the cosine of that some angle. Well, there you go. It'll be back to 2/5. It does cancel. I think we're okay on 6. 7, double checking. Sine of 5 pi over 3. Well, 5 pi over 3. 5/3 is, well, that's like, I'll do it backwards. 5 times pi is roughly 15. 15 divided by 3 is 3. Can I find the sine of 3 radians? Sure. Sine of approximately 3 is a valid number. No error. And it doesn't seem like there's an issue. Let's see if I'm in the right domain there. Arc sine of sine, is that similar to what we just did? Arc sine of sine has to be between negative pi over 2 and pi over 2. That's negative 1.5 something to 1.5 something. I think I'm okay. 8. Let's check our domain up at the top of this one. Looking at number 8. Are we allowed to take the cosine of a negative 4 pi over 3? 1 pi over 3, 2 pi over 3, that's that way. Go the other way around. Negative pi over 3, negative 2 pi over 3. How big is pi over 3? It's a 60-degree angle. So negative 1 pi over 3. Actually, I did it wrong up here. That was pi over 3, 2 pi over 3, 3 pi. Go in reverse, 1 pi over 3. Reverse, 2 pi over 3, 3 pi over 3. Right up here, it would go all the way backwards. Is there anything wrong with taking the cosine of that angle? I don't think so. Therefore, and the angle is in quadrant 2, which is allowed. Is allowed. Okay. I'm talking about angles that are in quadrant 1 or 2. So this one is fine. Okay, so we only found how many mistakes? Only found 2 mistakes. Number 3 and number 5 because of a technicality of the wrong domain. But mathematically it worked out. Number 7. Remember what quadrants I'm talking about for number 7. I'm only talking about is these 2 quadrants. Negative pi over 2 or negative 90 or positive pi over 2. So what is 5 pi over 3? How big is that? I might have to use a calculator, but 5 divided by 3 is approximately 1 2/3. 2/3 is roughly 0.66666. Wait, 5 over 3, yeah. 1 2/3. 1.6666. So is that falling in this interval? I'm led to believe that this does not exist. Because it's just slightly 5 pi over 3. If I was to draw where the angle goes, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. Oh, wait, I'm wrong. Never mind. It's okay. It's here. No, it's okay. It's in the right quadrant. It goes all the way down. So you can treat it in this quadrant here as the reference angle being negative. It will fall in the right place. We already did 8. Number 9. Tangent of what is pi over 3? Pi over 3 is roughly, I think, 1.7, was it? I have to use my calculator. Okay, it's not 1.7, it's not that high, but it's bigger than 1. Can you take the tangent? See, can the tangent of something, can it be greater than 1? Oh, yes, the tangent can be greater than 1. Because tangent has an asymptote, remember? Goes up forever. Sure, you can find the angle. So this answer will be pi over 3 with no reservations. Moving on to 10. Our cosine of cosine, we want to cancel it out and say the answer is 3/2, but let's be careful. First, can I take the cosine of a 1.5? You're going to find out that your calculator has no problem with this. But the rule was at the top that the answer would be x if we were in the domain between 0 and pi. Arc cosine of cosine of x. Arc cosine of cosine of x is x between 0 and pi. I want to say it because it works in a calculator, I'm sure. But his definition says restricted domain, so I guarantee you the author is going to say it doesn't exist because it's not in that domain. Sine of negative 11 pi over 6. Do the work inside first. Where is negative 11 pi over 6? Well, pi over 6 is a 30-degree angle. It's very small. So if I do 11 of them to the down 30 degrees, down another 30, that's 2, down another, so that's 3. So there's 3 every time I get to the 90 degrees. So there's 3, 6, 9, and 2 more. I'm in that quadrant. And that's an acceptable quadrant to be, according to our rule upstairs. So this is a legal problem. The answer should be, well, we're not going to say negative. I think we're going to say it's going to be up here. We're going to be in this quadrant here as positive. So that's going to be a positive pi over 6. Will be what the author is going to demand. Just like when we did the other lesson, there are other calculator answers or other graphical answers, but your calculators, we're talking about the principal angles. Next page. All right, find the exact values. So if we're doing this, handle your inside first. These ought to be less thinking because we're just going to be working inside out. So sine of pi over 6, do that first. That's a 30-degree angle. And sine is opposite over the hypotenuse. And opposite the 30 is always the 1. So this turns into arc cosine of a 1/2. Oh, wait. Sorry. Arc cosine of 1/2. See, they're not even the same relationships. They don't cancel each other out. I need to find out the cosine of what is 1/2. So that's going to take this triangle here with the 1, 2, square root of 3 again, and ask yourself what angle has the adjacent over the hypotenuse of 1/2. So adjacent would be this angle here. Adjacent over hypotenuse. Well, that can't be 30 because it's across the street from square root of 3. So that has to be a 60-degree angle. So in radians, x is going to be pi over 3. 14. Arctangent of cosine of 0. Do the cosine of 0 first. Ordered pair, 1, 0. Cosine has to be the x number. That's a 1. The new problem is arctangent of 1. Tangent of what is 1? That was this triangle here. 1, 1, square root of 2. What angle could either of these be? Pi over 4. These are easier. Arcsine of tangent of negative pi over 4. Negative pi over 4 is down here. Still a 45-degree angle. This is still a 45-degree angle. 1, 1, square root of 2, but be careful, this had to be a negative 1. So what is the tangent of this triangle? Y over x. Y over x. Arcsine of a negative 1. Sine of what's a negative 1? That has to come from the unit circle with one of these points. If this arcsine of a negative 1 means what angle has a sine of a negative 1? Well, even if you did your graph of a sine curve, you know that a sine curve looks like this. And when is it ever going to be a negative 1? When will the height be a negative 1, the lowest amplitude? You should know what that angle is because it's 1, 2, 3/4 of the way to 2 pi. You should be able to tell me what that answer was. But if you don't see it, go back to the dots. Where is y a negative 1 on the unit circle? Right here. 1 pi over 2, 2 pi over 2, 3 pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2. It matches up in that graph too. 3 pi over 2. But the ultimate question is, how would I report that answer if I have to be restricted to a positive pi over 2 to a negative pi over 2? I can't list that answer as 1, 2, 3 pi over 2. I have to go the other way around, negative pi over 2 to pi over 2. So I have to give the answer as negative pi over 2, even though it did work out graphically that also is true. But we have to give the principal angle, not just what we know. We do know it's here, 3 pi over 2, but I can't give that answer. They're being technical. We have to give the answer that's in the domain of arcsine. Gets confusing. All right. I like to think also when we're talking about these things, if we know that the only sine values I want, it's cosine values I want, are in these two quadrants, and the only sine ones I want are from here. But remember, this is negative pi over 2, and that's pi over 2. We're going this way, okay? For the cosine, yes, I'm going anywhere between here and here. So those are the answers your calculator is also going to give you, are in those quadrants. Even though, like the last problem here, we're sitting at 3 pi over 2, but 3 pi over 2 is the long way. The shortest way from the positive x-axis is going left. So you're going to find out that your sine and tangent will always be going either down to the negative up in that quadrant or up to that quadrant. It is confusing. Okay, now I want to work out number 16, the cosine of 5 pi over 6. Let's work on that first. 5 pi over 6. Pi over 6 is how big? Think about it. I have 1 pi over 6, 2 pi over 6, 3 pi over 6, which why it's 3 pi over 6 is pi over 2. So there's 3 of them there. I need 2 more. 3, 4, 5. We're talking about that. Okay, and since we're talking about cosine, is that an appropriate quadrant to be thinking about? I just got done telling you. We're good to go. So this is the triangle that I'm drawing. And did you remember that pi over 6 is 30? 30, 60, 90, 120, 150. So this is really a 150-degree angle. That must mean this reference angle is a 30-degree, or pi over 6. So what I'm doing is, where's I at? Pi over 6, that's 30. I'm doing arc sine of the answer to the cosine of this in this triangle. So that triangle, I'll superimpose it over here. There's my 30. That's a 1. That's a 2. That's a negative square root of 3. Okay? Because it's negative x value. So looking at this angle right here, what is the cosine of that answer? Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. And the adjacent's negative. So that is a negative square root of 3 over 2. So now I have to talk about arc sine of a negative square root of 3 over 2. Well, since now we're talking about a restricted domain for arc sine, I can't be in that quadrant. Arc sine only goes from in here. So where else is sine negative? Down here in that quadrant. This is still 30 degrees. This is still going to be, but this is now a negative 1. This is still a 2, and this is a square root of 3. So the question to you is, sine of what angle gives this picture? Sine of what? So now I'm looking back at that same triangle right here. Not this triangle. That was, well, let me look at this triangle. 1, 2, square root of 3. And this angle, this negative 30 is right here. But I need to know sine of what is this? So this is opposite. This is my hypotenuse. So the hypotenuse stays the same. But what is the sine that gives me this? Hold on here. So the answer is, what angle has this relationship? If I go to this triangle, if this is a 30 degree and I'm looking at a square root of 3 over 2, then opposite must have been this angle. If this was 30, that must be the 60. So we're talking about a negative 60-degree angle. Negative pi over 3 would have to be the angle that I'm allowed to use in this quadrant right here to give me the picture that matches up. Negative 60 degrees. Because sine of 60 is square root of 3 over 2. Sine of 60 is square root of 3 over 2. Told you they're difficult. All right. Tangent of pi over 4. Pi over 4 is typically in this quadrant, 45 degrees. 45 degrees. 1 square root of 2. What is the tangent of that angle? I hope you see it's 1. Y over x gives me the 1. My problem is arc cosine of a 1. So where do I go to talk about getting a cosine of something? Cosine of something, because this is my answer, has to be 1. Where would that be at? The only place I see an x value, remember what we said, if we're on the unit circle boundaries, we use the ordered pairs. We use that ordered pair. There's only one of those that has an x of a 1, and it's right here. Can cosine be on here? Can I use this value for? Of course I can. Cosine can be anywhere between those. So I'm going to say it's 0 radians. I'm using radians since he's got radians here. 18. Getting uglier. Arctangent of sine of negative pi over 2. Negative pi over 2 goes this way. Negative 90 degrees. I'm on the wall. I know for a fact on a unit circle that point is 0, negative 1. There's no triangle there, just a point. So what is the sine of a negative pi over 2? Well, I hope you remember that x is the cosine, y is the sine. So I'm going to say negative 1. Do you agree? So my new problem is arctangent of a negative 1. It has to be my answer. So I'm asking you, tangent of what is a negative 1? Well, I know what you're thinking. You're thinking it's on one of these points. And this point was 1, 0. This point is 0, 1. This point is negative 1, 0. This point is 0, negative 1. Tangent means y over x. Will any of those give me a negative 1? Is 1 divided by 0 a negative 1? No. Is a 0 divided by a negative 1 a negative 1? No. Is 1 divided by 0 a negative 1? No. Is 0 divided by 1 a negative 1? No. So it's not one of those. It has to be a triangle. What triangle has 1s in it? 1, 1 square root of 2. Ah, look at that. There's my x. There's my y. But I just need a negative 1. So, but what angle is this? It's 45 degrees, right? Or a pi over 4. But I need it to be, one of those values have to be a negative 1. So I have to draw my quadrants and say, well, where is sine going to be, or where is tangent negative? Tangent is negative in quadrant 2 and quadrant 4. The one I want is the one in quadrant 4 because of the restriction of arctangent. Arctangent is in this quadrant and this quadrant if you go backwards. Don't go all the way this way. That's too big. It's too long. You have to take the closest to the x-axis. So that 45 degrees would be a negative 45 degrees. Or x is negative pi over 4. Okay. Going in reverse. Arc sine of 1/2. In other words, sine of something has to be a half. Well, that's a nice triangle that we've looked at before. 1, 2, square root of 3. What angle would be opposite over hypotenuse of 1/2? What would that angle be? You're right, a pi over 6, or 30 degrees. So I'm asking, what's the cosine of pi over 6? No. Cosine of pi over 6 is here. There's my 30 degrees right here. 1, 2, square root of 3. And I'm in the right quadrant because cos is going to be restricted to those two quadrants. So cosine is adjacent. Where am I at? Cosine would be adjacent. Cosine is adjacent over hypotenuse. The hypotenuse is a 2. Adjacent is the square root of 3. There's your answer. Square root of 3 over 2. Arctangent has to be 1. Okay, don't fall for that trick. It's not on those 4 points. Where did I do all that work with all those 4 points? Somewhere. Did it somewhere here. Where would I do all that fun work? Oh, right here. Remember, I did all the y divided by x, y divided by x, y divided by... None of those will give you a 1 for tangent. The 1s only appear on sine and cosine, not tangent. So this must be that special triangle. 1, 1, square root of 2. Tangent of what is 1? 1 over 1. That's a 45-degree angle. So what am I doing? I'm doing sine of a pi over 4. Pi over 4 is in quadrant 1, appropriate for sine, and it's appropriate for tangent. So either way, it's a win-win. So if this is a 45-degree angle here, 1, 1, square root of 2, wouldn't the sine be opposite over hypotenuse? 1 over the square root of 2? Of course, we're going to rationalize it like good boys and girls do. Square root of 2, square root of 2, square root of 2 over square root of 4, which is 2. That's the answer I'll stick with. Continue. Sine of arc cosine of 0. So when I'm doing this part, I'm asking for cosine of what angle has to be 0. Okay, that has to be on one of those points. How about this point right here, 1, 0? Is cosine 0 there? No, cosine is a 1. Is cosine 0 up here, 0, 1? Yes, no. Cosine is cosine, well, yes, cosine is 0, 0, 1. That works. There can only be 1. What's that angle? 90 degrees, or pi over 2. So I know in this case, I'm looking for I'm looking for the sine of pi over 2. Sine of pi over 2. Pi over 2 is up here, and it's perfectly fine for the sine values because all sines are going from here to here, negative to positive. The sine is the same ordered pair, should be 1. Check it out. Cosine of arctangent of a square root of 3. Tangent of what is square root of 3 over 1. Why did I write over 1? So that I could say opposite over hypotenuse, or I could say x over y. Is there a triangle that has a 1 and a square root of 3 in it? There is. It looked like this. 1, 2, square root of 3. But it's obvious by hypotenuse. Let's see, x over y over h, x, y, horizontal, vertical. So what angle would I be talking about with a square root of 3 over the 1? What's the angle here? Because the opposite has to be the square root of 3. What would that angle be? Did you say 60 degrees? You would be right, because this would have to be 30 in order to be across the street from the 1. So I know here I'm talking about a 60-degree angle. So my new problem is cosine of pi over 3. Well, where's pi over 3 at? Pi over 3 is 60 degrees. It's right here, 60 degrees. There's my triangle. Cosine is allowed to be in these two quadrants. So this must be a 30 right here. That's 30. So that must be a 1. This must be a 2. This must be a square root of 3. All of them are positive. What's the cosine of this angle right here? Adjacent over hypotenuse. 1/2. Okay, we got more to go. He wants me to let the inside equal to theta, determine which quadrant theta must lie in, draw a right triangle. That's what I've been doing. I've not been doing anything different. Oh, I know what he's doing here. I'm only going to do, there's only 2 of them anyway. These aren't special. Oh, he even says non-unit circle values. So when I ask you cosine of what is 8 over 17, you're going to say, I don't know. This is purely a calculator problem, unless you can make a triangle and do Pythagorean Theorem. So without the calculator, let's see. Cosine of what is 8? So adjacent would be 8. Hypotenuse would be 17. I would have to find that side. Why do I need that side? Because I need the tangent of the answer. Tangent is y over x, or opposite over adjacent. So I need to use Pythagorean Theorem. So yeah, some of us still need our calculators. I'll call that a y that I don't know. Y squared plus 8 squared has to be 17 squared. Y would be the square root. Move the 8 squared over, which is 64. What's 17 squared? I don't know. I need a calculator. 49, that's 13. No, it's not. That's 11. That's a 7, that's a 1, 9, 8, 289. I should have known that. That's 289. So y would be the square root of 289 minus 64. 289 minus 64, 5, 2, 225. The square root of 225 is 15. So I know y is 15. So I need the tangent of this angle right here. That answer, well, actually I called it x. The tangent of that angle, x, well, I can't call it x now because I should use theta. That's what the author said. Why didn't I follow directions? I already used the x over here. I called this x. I called this is x, and I called this is y. So therefore, it'd be better to call that theta. So tangent of theta has to be what? There's my triangle. 8, 15, 17. Opposite 15 over my 8. There's the answer. But I had to use Pythagorean Theorem to get the missing side. Okay. So what we're doing here, if I follow the directions, I'm going to find sine of theta, whatever sine of theta will be. Theta will be the arctangent of a negative 12 over 5. Okay, so where am I at? Oops, let me finish drawing that. Triangle would look like this. If tangent is negative, it has to be in quadrant 2 or 4. Since the principal values of tangent are in these two quadrants, I have to take the angle down here, but I have to make it negative. Because tangent of theta is negative 12 over 5. Which of those values get the negative 12? The y value. This stands for y. This stands for the x. So this is a negative 12. And this is the 5. What do I not know? I do not know the hypotenuse. So I'm going to have to use Pythagorean Theorem. 5 squared plus a negative 12 squared has to be the hypotenuse squared. 25 plus 144 has to be h squared. That adds up to 169 equals to h squared. Take the square root, both 13 equals to h. So there's my prodigal child, 13. Let's answer the question. Sine of theta. What is the sine of this angle that I don't know what the angle is? I still don't know the angle. It doesn't matter. I want the sine of this angle, this mysterious angle, which is opposite over hypotenuse. Well, what was the opposite? The opposite's the negative 12 over 13. Hope that makes sense. If it doesn't, or I made a mistake in any problem, be the first to let me know. What's next? Your homework. You got one page? You only have one page of homework? Wow. Okay. Have a good day. Oh, just one.